So today I'm going to prove that if A is a nilpotent matrix, that I minus A is invertible. To do that, I'm going to start by using the equation, just equality, I guess. I minus A equals I minus A. And then I'm going to let the B matrix I minus Actually, I'm going to let that equal I plus A squared plus A cubed plus dot 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 plus A to the K minus 1. And I'm going to multiply that on both sides of this equality. So on the right, actually. So I minus A times B equals I minus A times I plus A squared plus A cubed plus dot 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 A to the K minus 1. Okay, so we're going to deal with the right side of the equation here. And that's going to equal I squared plus IA plus IA squared plus IA cubed plus I dot 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 plus I A to the K minus 1 minus AI minus A squared minus A cubed minus A to the 4th minus dot dot dot, which A to the 4th really could go in the dot dot dot, minus A to the K minus 1. Okay, so here's what we got to work with. Let's see. Anything multiplied by the identity is simply itself, and that goes for the identity. So we could simplify this to equal I plus A squared plus A cubed plus dot 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 plus A to the K minus 1. And then for this side, it's going to be minus A squared minus A cubed minus, and A to the 4th power is going to go in the dot dot dots, dot dot dot, just because the powers all the way up to A, and then minus A to the AK minus 1. Okay, so now we're going to focus in on how we can simplify these bad boys, because as we can see, this cancels. Okay, so then that's going to equal I plus A to the K minus 1 minus A to the K minus 1. Okay, so A to the K minus 1 and A to the K minus 1. This can be broken down into from the exponents law, which states, I'm going to get a little side note. From properties of exponents. A to the K minus 1 equals A to the K minus 1. And A to the K minus 1 equals A to the 1, a to the k, and a to the minus 1, which equals a to the k. Okay, so which now we're going to switch back to colors, equals I a to the k, a to the k minus 1, minus a to the k. Okay, so from, scroll up a little bit. Another side note, from properties of nilpotent matrices, a to the k equals 0. So we could sub that back into here and into here. And that's supposed to be a plus, sorry. So this equals I plus 0 minus 0. And that pretty much just solves our proof. So if we go back up to here, we can see that I minus A times B, these cancel, or 0, it doesn't matter, equals I. So from this statement, we can say that, therefore, I minus A is invertible. Ideally, oops. That's how you spell it. Yep. And B is equal to minus A inverse, because I minus A B equals the identity. And that is going to sum up that proof.